One thing that I just wanted to make clear from the very beginning, my name is Alex Stone and I do work here at OSU, but I am not a plant breeder. And so I'm mysteriously on this panel, and I am working on winter squash and I am working on cultivar evaluation, and so I am going to talk about that, but I also thought that the other thing that I would do is just sort of make some comments about, I'm really just going to talk about sort of 4 different aspects of the work that we're doing, some ideas that we see that would be good things for a plant breeder to work on, in addition to our work on cultivar evaluation. So that's the approach I'm taking. So I just wanted to introduce somebody, actually Taz Tennell over here, who's one of our eOrganic technicians. He's done a lot of the work on this project. He's serendipitously here helping to do the broadcast. I wanted to just point him out here. So anyway, I'm going to be talking about this project that we're doing, primarily on maximas and primarily on kabochas and buttercups, but we also do work with some other species and cultivars. And our goal is really to help facilitate the growing and eating of profitable, long-storing, and delicious winter squash. A very small goal. And again, not a breeding project. So the goals really are to, I really sort of see farmers as my primary clientele. And the farmers I work with, some of them really struggle with making winter squash profitable, particularly if they try to store it. So one of my primary goals, and really the driving force behind all this, is to help the farmers find cultivars and mostly sort of cultural practices to make squash production and storage more profitable, especially for sales at this time of year. And most of the farmers I work with do not have squash for sale at this time of the year because they don't have cultivars and they don't have storage systems that allow them to do that profitably. The other thing that I'm interested in, and also the farmers I work with, is finding cultivars and squash production and storage systems that are more sustainable. For example, that require less water or require less energy. And the other sort of really big goal is that we would really like people to eat more squash, not just in the fall, but also in the winter, because squash is really nutritious and it's a great winter local food that isn't really currently being grown and marketed locally in the midwinter. So I'm first going to talk a little bit about field production issues. One of the things that we hear over and over is that winter squash are really big, and what people really want is something really small. So we have this sort of mismatch between the size of most of the winter squash and what people want to have to buy and eat. So here are some cultivars, Blackfootsu, Shokichi Shiro, and Gill's Golden Pippin, and we haven't done much work on their yield, and I'll talk a little bit more about yield in a minute. But we have been storing them and we have been tasting them. And all 3 of these squash are both long storing and really good tasting squash. So I think they have a place in the midwinter squash production and storage regime. And we do need to work more to figure out how to make them profitable. The other thing that we've been looking at in terms of making squash smaller, and this is when we're working with the sort of more mainstream squash, and in particular I've been working with kabochas and buttercups. A lot of those, particularly those that are high yielding, are really large, like Sunshine and Sweet Mama and Winter Sweet and Bonbon, which are some of the ones that you see here. They're also sort of inherently not very high yielding when you compare them to other squash, for example, butternuts. Those are inherently higher yielding, partly because they put out more fruit per plant. So one of the strategies to try to actually just improve yield with some of these plants that don't put out many fruit per plant is to increase the planting density. And so we've been looking at that, and I'm just showing you here the impact of planting density on fruit size. And as you see in this figure, if I can figure out how to use this pointer, generally speaking, fruit size decreases with increased planting density. And so that does increase yield, and I'm not showing you the yield figure, but the other aspect of that is it does reduce fruit size, which possibly could be a bad thing, but typically especially with these large fruited cultivars, that can actually be a good thing. So not only do you increase yield, but you can get some of these large fruited cultivars down to a size that is more manageable for many consumers. So one of the sort of breeding suggestions here is to sort of breed for smaller fruited cultivars that have more fruit per plant so that you can increase yield, and that also select for their production under high density, high plant populations. So another thing that's of great interest here in the West, particularly with climate change, is growing vegetables without supplemental irrigation. And there are farmers in the West, and in Oregon actually, who are commercially growing dryland squash organically very successfully with some particular cultivars, and one example is actually some of the delicatas. So I was very interested in this, and so you see here a photo of our field trial this year, which was really just a preliminary screening trial. We basically just had 2 rows of winter squash grown in the middle of this big field with 2 lines of irrigation running alongside. I mean, no irrigation. 2 irrigated crops on either side, but very widely spaced. So this was just 2 rows of squash running down the middle of the field. And basically there was just 10 feet and about 4 plants of each of the cultivars. So it was an unreplicated trial, and it was really just a screen. And what I expected, and it was a very hot, dry summer, and what everyone at the research station expected was that a lot of them would just be very unproductive, and then a few would stand out. But what we see, and this photo was taken in October 10th, and our irrigated trial actually had a lot of plants that were down on the ground from powdery mildew and other problems. And the vigor of these plants into the fall was actually very strong. So, and most of them produced very well. We don't have yield, we took yield, but it's not good yield data because it wasn't replicated and because the spacing is so bizarre in this kind of a screen. But it did look very promising. So you see I just took this picture this morning actually. These are some of those fruits from that dryland trial. And a lot of them are storing really well, and the quality seems very high. And we really did grow a great diversity of cultivars. Some of the things that were really interesting about them that would be of very great interest in organic production was that we had a really big cucumber beetle spring this year. And they were killing young squash plants. And we had to spray in our other trials. But in this trial, we actually never sprayed for cucumber beetles, and there were very few of them present. And I don't know whether it was a timing issue or whether it was really that dryland squash production may help deter them for some reason, but that would be something that would be of enormous interest to organic farmers. And also there are very few weeds because we weren't irrigating, except for purslane, which thought it was the greatest thing that ever happened. We had these gigantic purslane plants out there. I thought there might not be any edema, which is that sort of physiological problem you see where the fruit touches the soil. And we did see less edema because it's water related, but there wasn't no edema. It seems like it's possible that at least in some cultivars, dryland production could actually improve storage duration and quality of the fruit. That's something that we would be interested in looking at. It's possible sort of qualitatively that that's going on in storage. And one of the big questions really is would this impact sensory quality? And I'm going to talk about sensory quality later. We haven't done a sort of comparative trial or comparative sensory evaluation, but we have been eating the dry farm squash, and certainly they're not inedible. We can't randomly detect any sensory differences, but we might be able to cook some up and test them side by side later this winter. But that's a big question. So certainly here in the West, and the other issue that I don't have on the slide is that we have a serious soil-borne disease of cucurbits here that really impacts yields. And typically soil-borne diseases are less severe when the soils are drier. A lot of them are moisture related. So it is possible that growing them under dryland conditions, even if the yields were lower, if you were in a soil that had a lot of inoculum in it, that maybe it would even be kind of a wash in terms of yield. So that is a possible benefit too. So moving on to storage. Storage is also a big issue. You put squash into storage around here, and in some cases you can lose the entire thing to storage rots. So we're interested in working also on storage. So typically the recommendation that you read in extension publications is to keep squash, when you put them in the storage, put them at 50 degrees Fahrenheit or over, because squash is susceptible to chilling injury if it's stored for a long time at below 50, and also at 50 to 70% relative humidity. So most of our data, and I'm not really showing a lot of data today, but we do have a lot of storage data, and we are keeping most of our squash in a dehumidified walk-in at 55 degrees Fahrenheit and 60% relative humidity. But one of the things we're really interested in is what we call shackability. And that's the ability to store squash under shack conditions. And such as these two photos that you see here, one is a closed barn bay. This is part of the potato program here. So there's no heat in here, but there is a door. And then in the next bay, and there's a door between the two bays, there is a walk-in with a reefer. So it keeps this at around 40 degrees. And we do have a hobo in there measuring humidity and temperature. And then the true shack is our equipment bay that we do a lot of work in, and we keep squash in here, and we've actually had some squash in there that we've never brought into this closed bay, although some of them we move in and out between the two to just try to keep them above freezing. And what we found is that it's true that a lot of cultivars do exhibit chilling injury, but not all of them. And so what we're interested in is finding the ones that don't, because then farmers could store them in our mild winters here, and at much less expense and much reduced use of energy. So this is a squash that seems to have enormous shackability, called Tetsukabuto, which mostly is used as a disease-resistant rootstock that melons and watermelons are grafted onto. But Shinji Kawai, who works with Jim Myers in the breeding program, is from Japan, and he said, Tetsukabuto is eaten in Japan. It's a winter squash. And so we grew it this year. It's very high yielding, but it is really just sort of indestructible in a shack. And so we want to pursue looking more at, its quality and ripening over time under shack conditions. But what you see here in this picture actually are also taken today was the quality, or what Tetsu looks like when it has been stored in that dehumidified walk-in since harvest versus the one in the barn bay. And you are going to be tasting this squash in the tasting later today, and you're going to be tasting these squash that were basically shacked. Tetsu ripens, as you see here in this lineup. We are going to be sort of trying to figure out what the difference in sensory quality are as it moves through this ripening process. But we have been eating these, and they are quite good tasting. So that's kind of exciting. So I guess a breeding thing and also an evaluation thing that we're doing is trying to figure out how to find squash that are shackable, profitably shackable. So the last thing I'm going to talk about are culinary uses and sensory quality. And this comes back to trying to get more people to eat more squash. So we want to make them excited about squash. Like, people love the looks of squash, and then they'll buy them, and then they'll take them home, and then they won't eat them. And I'm as guilty as the next person in doing that. So what we want people to do is not only buy them and think they're beautiful, but then to come home and eat them, so they go out and buy another one. And they are actually eating squash in the winter, which could only be a good thing. So I have worked with Lane Selman to do sort of preference analysis on different squash cultivars, and I'm not going to talk about that. And you're going to be doing that later today. But more recently, we actually have been working with Chef Tim Westell, who's doing the tasting today with you, and Lane, to try to more quantitatively evaluate squash flavor and quality, to distinguish amongst the varieties, but also to see how they change in storage, and then to sort of relate that to culinary uses. And so here you see some of the questions that we have that we're trying to answer. Like, do kabochas as a group taste different than buttercups as a group? And that's not true. They actually sort of vary by individual cultivar. Do flavor and texture change over time? well, that's very likely, and we have a little bit of data now to say, yes, that's true, and now we could actually describe how they change. And is there a variability in the flavor and texture of fruits of an individual cultivar? And that's true, and we're going to try to get more of a handle on that and trying to figure out how we could, and that might be something again to breed against so that you have less variability in that in a squash. So this is just an example of the data that Tim has been collecting with us. This is the kabocha cultivar Sweet Mama, which has performed very well in many of the evaluations we're doing. He tasted it raw, steamed, and roasted. This is just data from a single fruit in early December that we also did bricks and dry matter on, and it was really at perfect ripeness. And basically you see here, these are 6 variables related to texture and 5 related to flavor. And we came up with these all together, thinking about flavor wheels and flavors that Tim and textures that Tim thought as a chef were characteristic of squash and could distinguish amongst squash. And what he said here is that the raw, steamed, and roasted applications were all really good, and they were all really different, and that sort of picked up in his evaluation here. One of the things that I thought was really interesting is that I don't really think of kabochas as being something you'd want to eat raw, and we don't really think of eating squash raw, but kabochas even less so. But he actually very highly rated Sweet Mama at that time as for a raw application. So I think one of the things that we could do is really try to think of novel uses, and people are eating more, trying to have more plant-based diets. Winter squash can be stored on a countertop, so it's something that has that sort of convenience and non-perishability factor that would be really great in a salad product, I think. This is a salad that Tim made as part of what we called Squash Party. It was a culinary and sensory event about winter squash in Portland last winter, and he made this raw squash salad with radicchio and black futsu. You're going to taste a salad similar to this. It's sort of a variation on this with raw black futsu in I believe it's the chicory section of the tasting, not the squash section of the tasting. So go look for that squash. But I think there's a lot of opportunity potentially to breed squash, for example, particularly to be used for salads, as well as other novel uses. Tim also made an ice cream out of Muscat de Provence, I think, at that same sensory experience that we had in Portland last winter. And I think that is all that I have. Thank you very much.